All right, folks. So I don't know what happened today with the attendance and exit ticket extra credit problems. Um, they're pretty much in line with some of the concepts we've been learning in the last couple of weeks, not really too different from a lot of the problems we've done on quizzes and practice assignments, either classwork or homework. But it does seem that we did struggle with these particular questions. Not a whole lot of extra credit went around, but don't worry, there will be more opportunities later in the week. But just to kind of bring you up to speed on how we reach the correct answers on all three of those problems, I'm going to write them out here for you, or have written them out here for you. I'm going to go through them just to kind of refresh and make sure that we do have those concepts fresh in mind. So we're going to start with the one that asks for 12% benzoyl peroxide, which is just abbreviated as BZO2. All right. Description calls for 50 milliliters of 8% benzoyl peroxide. Okay. So we're going to use a certain amount of this 12% to get a solution that is 50 milliliters in total volume, and that's going to have a concentration of 8%. Okay, so we're going to mix it with, it doesn't matter what we're mixing it with. We're mixing it with something to make up that volume that doesn't have any benzoyl peroxide in it. Okay, so we're using some amount of this mixed with whatever our base ingredient is to get 50 ml solution that's 8% benzoyl peroxide. Okay, so we're going to set up a standard alligation grid because we have everything that we need. The problem doesn't spell that out for you. The problem doesn't say that your lower strength concentration is 0%, but that's a given. It's implied. It logically follows that if you're mixing some amount of 12% with something else and trying to get 50 ml of 8%, that the something else you're mixing with, since they didn't specify a strength, is something that does not contain benzoyl peroxide. So it's 0. All right, so you're going to set up your alligation grid, X out, north, south, west, and east. You're going to put 12 in the appropriate spot for higher strength, 0 in the spot for your base. Remember, that can be a water, it can be like a petrolatum, whatever it happens to be that you are diluting your medication with. We're diluting this 12% down to 8%. We want 50 ml. 12 is the higher strength, 0 is the lower strength, and 8 is the target strength. So we just do our standard cross subtraction. Difference between 0 and 8 is 8. Difference between 12 and 8 is 4. Okay, so we have 8 plus 4 is 12 parts in the whole. On this top line, our 12% concentration of benzoyl peroxide, we're using 8/12, 8 parts of 12 total parts. Okay, and that reduces down to 2/3, which we know is approximately, rounds to about 67%. Down here, how much of the whatever it is, the base that has 0 benzoyl peroxide in it, how much of that are we using? 4 parts out of 12 parts, 4/12, or 1/3, which we know is roughly 33%. All right, we want to know how much of the 12% we're using. So we just take 67% of 50 ml, and that's going to give us our answer. Okay, so if you selected something other than 33 milliliters, then you used a different path to get there than simply filling out your alligation grid with the information you're given in the problem, and then completing it as we know how to do. So 33 ml. For the second, we have a prescription that wants 500 milliliters total volume of 4% saline. Now, again, this is another one where they didn't give you 2 different concentrations, but it's implied, it's understood that you know how to figure that out, okay? Because we told you that you have 10%, and they also said that you have normal saline, and you are expected as a pharmacy technician to know that normal saline is 0.9%. which is less than 10%. Consequently, you know where to plug those into your allegation grid. And we know that we want this final 500 milliliter volume to be 4% saline. So we have our target. So we have everything that we need to set up the grid and solve using the tic-tac-toe method. So the difference between 4 and 0.9 is 3.1. Difference between 4 and 10 is 6. So we end up with 3.1 plus 6, 9.1 total parts. Proportionately, we have 3.1 of 9.1 parts of the 10%, which if you just on a calculator divide 9.1 into 3.1, you get roughly 34%. For the normal saline, we have 6 parts out of 9.1 total parts, which 6 divided by 9.1 gives you roughly 66%. They want to know how much of the normal saline we're using to get this 500 ml. So that's simply 66% of 500, which is 330 ml. Okay. And then for the exit ticket problem, this one doesn't require setting up an allegation grid. This one you kind of just have to look at, and you kind of need to remember what we were told about the density of water or any aqueous solution that is essentially close enough to water, okay, that we can assume it has the same density to within, you know, a 100th or 1,000th. We know it's 1 gram per 1 milliliter is the density of water. Okay, most aqueous solutions that we're dealing with in pharmacy are not going to stray too far from that. Milk, I believe, whole milk bought in the grocery store has a density of 1.04 to 1. So really, we're not going to be compounding anything in the pharmacy that's going to go much beyond that. So really, we can always assume that 1 to 1 is going to work for density. Okay, that means if we know that we have 100 milliliters with 50 milligrams of drug X, we know that we're saying there's 1 gram in a milliliter. That means 1,000 milligrams in a milliliter. That means that this 100 ml has 100,000 milligrams of water, or 100,000 milligrams of solution. Okay, and all of that is water, except for the 50 milligrams that is medicine X. So it's 50 over 100,000, which is 0.0005 expressed as a decimal. And obviously we know if we want to get a percentage, we're just going to move the decimal 2 spaces over to the right, and we get 0.5%. All right, so these ones were actually fairly simple and straightforward. I think the part that might have tripped people up is they don't spell out all the information for you, but that's not always going to be the case, especially on a standardized test. They are sometimes going to assume they are able to take those extra steps and infer from the information that they gave you, that they supplied, what you need to solve the problem.